Hi, my name is ErikaJ2.
And I'm Jamie Menard.
And this is our rocket project.
The goal of this project was to send our rocket as close to 700 feet as possible and return a payload consisting of an altimeter, accelerometer, camera, and raw egg safely back to the ground.
To do this, we had to consider a rocket's balance between factors such as mass, structural integrity, parachute size, and more. The project could be split into 3 parts: design, construction, and flight data analysis.
Our first major design choice was the fins for our rocket. After a lot of research online, we found that multiple sources recommend parallelogram-shaped fins for a rocket of our size.
After finalizing our design, we laser cut our fins with balsa wood. We decided to use 4 fins to make sure our rocket was as stable as possible while in flight.
We followed the recommendations for the maximum body size, keeping the total length 18 inches. The payload was 8 inches and the body tube was 10.
The motor mount consisted of a motor stop ring, the motor mount tube, engine hook, and centering rings. We followed the directions for assembly as given to us in our class packets.
After adding the motor mount to the rocket, we added the fins. We measured and drew on the rocket to ensure that the fins were equally spaced apart and straight. We decided that anything we glued to the rocket, it would first be glued down with Gorilla Glue for quick drying, then reinforced with wood glue.
While working on the construction, we were simultaneously recording all of our measurements onto OpenRocket. This way we could run an accurate simulation of the rocket at the end of construction.
In constructing the payload section, we inserted half of the balsa stopper into the payload tube, screwed the metal eye socket into the outside end, and attached the cardboard nose cone mount, and drilled a hole for air and camera access.
Before constructing the parachute, we had to glue the shock cords into the top end of the body tube. Next, we made the parachute as big as we could. This would ensure that the rocket would fall smoothly, keeping the egg intact. The parachute was an octagon with a diameter of about 15 inches, maximizing the amount of material given to us. Initially, we had noticed a discrepancy between our physical rocket's weight and that of the recorded weight on OpenRocket. After combing through the data, we still could not account for about 50 grams. Before the flight, we added 36 grams to the rocket's 3 rings, because our simulation on OpenRocket predicted around 750 feet with its simulated mass.
Everyone in the class used E9-6 rockets, which burn for about 3.1 seconds, then deploy the parachute after an additional 6 seconds.
The flight was a success. Everything deployed as it was supposed to. The rocket came back perfectly intact and the egg did not crack. The target height was 700 feet, and our rocket reached an altitude of 601 feet.
Other than the height, the launch went off perfectly. As you can tell from our data, the engine burned for about 3 seconds, and the parachute deployed at about 9 seconds, which was 6 seconds after the burn ended, as predicted.
Overall, we learned a lot about different rocket terminology, and through research, learned how different fin shapes could affect a rocket of our size.
The only thing that we would change is the weight added last minute. We believe OpenRocket overestimated the height of our rocket without the extra weight. This could be because it is hard to take into account all the weather conditions at the exact time of the launch. Other than that, we are very pleased with our results.